so as promised, it's 4:05 on dot. So to everyone that is just joining us, we say good evening and welcome to the second webinar of World Space Week 2025, theme Living in Space. If you can hear me, let me see your virtual reactions, please. Thank you, David. Thank you, Judith. Thank you, Sylvester. Thank you, Victor. Thank you, thank you, thank you. All right. So once again, I welcome you to today's webinar, which theme is Space Robotics and AI. Space Robotics and Artificial Intelligence, right? With a sub-theme, how robotics and AI help astronauts perform tasks. Space robotics and AI. As when I first saw this topic, I was really intrigued because I'm a very curious person, right? And so when I see topics like this, I'm usually very excited because I like to learn more. I like to learn about new concepts. So when I saw the topic, I'm like, I would not miss this webinar. So Mr. Yusuf, I hope you would make this webinar worthwhile for each and every one of us because I am really curious and I am really intrigued to know how robotics and artificial intelligence help astronauts to perform tasks in space. So once again, I say welcome to each and every one of us attending the last webinar or the second webinar for World Space Week 2025 theme Living in Space. If you're excited, can I see your virtual reactions, please? Yes. Thank you, Victor. Thank you, Abdulaziz. Thank you, David. Thank you, Sylvester. So now, if you know people who have registered or you have friends that you know who have registered or will be intrigued or curious about a webinar like this, please let's not be selfish. Let's go to their WhatsApp and tell them that we've started and they would not want to miss this amazing webinar. So let's do that quickly. If you know people who have registered and are not on this call right now, let us try to tell them that we've started and it will be a bummer if they miss this session because this is the second to the last event that we are going to be using to wrap up World Space Week 2025. So if you are not here, I'm really sorry for you. I really am. So let's try to tell people to join us that we have started. All right, so my name is Mercy Obano, and I'm your host with the most. I would be your moderator for today's webinar, Space, Robotics, and AI. How robotics and AI help astronauts perform tasks. So moving on quickly, we would be having the welcome address by the one and only, the president of Space Club's LASU, Mr. Sylvester Agose, also known as Agobaba. So Mr. Agose, you have the floor, please.
All right. Hi, everybody. Good evening. Thank you very much, Mercy, for that one. Good evening, Mr. Yusuf. Good evening, everyone.
Good
On
evening.
behalf of Space Clubs of Lagos State University, I want to really welcome every single one of you to our World Space Week 2025 webinar on space robotics and AI, how robotics and AI helps astronauts to perform tasks. Now, this year's theme is what I consider to be a very powerful one because it shows how far technology has come and how tools like robotics and artificial intelligence are making space exploration safer, making it smarter, making it more efficient, right? From operating in very harsh environments to assisting astronauts in very little tasks or very difficult tasks. These innovations are helping change how we live and how we work in space. And for those of us who are new here at Space Clubs LASU, we are very passionate about helping students learn, helping them build and helping them imagine beyond limits. And this session or sessions like this give us the chance to connect with experts, to share ideas, and to get inspired to create the future that we all want to see. Right. So I want to thank every single one of you once again for joining us today, to our speaker, Mr. Yusuf, to our guests, and to every single participant. I hope that this session just leaves you with a heightened level of curiosity and leaves you inspired. So welcome once again. And yeah, let's just enjoy this conversation. Thank you very much. Over to you, Mercy.
Thank you very much, Mr. Agose. A round of applause for Mr. Agose, please. All right. So on behalf of Space Clubs LASU, we say welcome and good evening to each and every one of you. So right about now, I am going to be doing a little introduction about World Space Week. I mean, we've been saying World Space Week for the past 1 week and even prior, right? Especially if you're on the Space Clubs LASU general group. I'm sure every single day we have something to post about World Space Week. So what is this? What is this World Space Week? How did it come about? Why are we so interested and intrigued in celebrating this event? So World Space Week came about through the United Nations in 1999. The UN General Assembly declared October 4th to October 10th every year as World Space Week. So you may ask, why October 4th and October 10th? Why not November or December or my favorite, December, right? So why those dates? So they mark two major milestones in space history. The first, October 4th, 1957, was the launch of Sputnik 1, the first artificial satellite, which kicked off the space age. So the first artificial satellite was launched on October 4th. So that is why we are beginning World Space Week on October 4th. So do we all get that? Now, the second milestone in space history was on October 10th, 1967, exactly 10 years after. I don't know, am I the only one that finds it like kind of ironic? October 10th, 10 years after. Right, so this was the day the Outer Space Treaty came into effect, a landmark agreement that guides the peaceful use of outer space. And so here at Space Clubs LASU, we celebrate World Space Week not just as spectators of global progress, right, but as active contributors. Young Africans proving that space belongs to each and every one of us, whether it's through robotics, AI, medicine, data analysis, economics, design, computer science. Every one of us here has a role to play in shaping how our continent engages with the universe. So, as we journey through today's session on space, robotics, and artificial intelligence, I want you to see it as more than just a technical conversation or a technical session, right? But as a glimpse into the tools that will define the next generation of space exploration and space discovery. So a round of applause for me, please. Let me see your facial reactions for me. Thank you, thank you, thank you. Right. So now, quickly, we'll be taking the webinar etiquette, the do's and don'ts of this webinar to make sure that things flow smoothly and in accordance. And to anchor that, we'll be having a CK piece. So a CK, you have the floor.
Hello,
Is peace on the floor, please?
good afternoon,
All right.
everyone. Yeah, I'm on the call. All right. Good afternoon, everyone, and welcome to this evening webinar as we continue World Space Week, day the se- the 8th. So the webinar goes thus. I would like everyone to adhere to this webinar etiquette. One, ensure your microphone is muted at all times. Two, raise your hand if you want to speak. Three, use the chat box for questions and complaints. Four, ensure your headphones are not too loud so you can hear alarms in case of emergencies. 5. Make sure you are in a quiet place before you speak or ask questions. 6. While speaking, avoid the use of vulgar or inappropriate words. Thank you very much as you adhere to this webinar etiquette, and let's have a great time.
All right, thank you so much, Peace. So now, a round of applause for Peace, please. So now we will be doing the introduction of our partner for World Space Week, SGAC. So to anchor that will be Judith. So Judith, you have the floor, please.
All right. Good evening, everyone. Please confirm you can hear me. Thank you. The Space Generation Advisory Council, SGAC, is a global non-profit organization that represents students and young professionals aged 18 to 35 who are passionate about space. Founded in 1999 and recognized by the United Nations. SGAC serves as the official voice of the next generation in the space sector, It connects over 27,000 members from more than 165 countries, making it the largest youth space network in the world. Through programs, conference, and global collaboration, SGAC creates opportunities for young people to learn, lead, and contribute to real space initiatives, from policy development to innovations and outreach. They work closely with major organizations like NASA, the European Space Agency, and the African Space Agency, giving members access to mentorship, training, and international exposure. So when we say we are proud to partner with SGAC, it's because we are aligning with a network that is empowering young people across the world to actively shape the future of space exploration and development. Our partnership with SGAC is a step toward empowering young Africans to take part in shaping the future of space, connecting our community to a global network of thinkers, innovators, and leaders driving humanity's next great adventure. Thank you.
All right, thank you for that one, Judith. So you've heard, you've heard about our partners, SGAC, right? So a round of applause for Judith, please. So now moving on, before we go into the main event of today, we will be having a remark from NSS representative, Mr. Victor Dennis. So Mr. Victor Dennis, you have the floor, please.
All right. Good afternoon, everyone. Good evening. Good day. I hope I'm audible. Can you hear me?
Yes, we can.
Okay. All right. My name is Victor Dennis, and thank you very much, Mercy. My name is Victor Dennis, and I'm the events director for the NSS. The NSS is actually the Nigerian Space Symposium. All right. And also, I am the regional communications manager for SGSC for Africa. So, briefly, I would just like to say a thing or two about the NSS. So, um, actually, the NSS is an event, right? It's an annual event, right? That seeks to bring together people, particularly Nigerians and Africans at large, all right, connecting people together so that we can come to share ideas, network with one another, celebrate ourselves and recognize each other's contributions in the Nigerian space sector. All right, that's worldwide. So this is irrespective of wherever the locations are. That's wherever people live, or yeah, and things like that. So we're looking at bringing people together to connect with one mind, right? Within the space sector in Nigeria. So also we're dedicated to recognizing and aligning the hearts of Nigerians to space, right, to space activities, right, and this cuts across several space sectors. It cuts across the academia, industry, the military, government, private innovators, and global partners. All right. So we've had several events in recent years. Last year, upper year, we had several events spanning from that started from SGSA. So we had the SG Nigeria, we had the African Space Generation Workshop. They all had here in Nigeria. This was like about last 2 years and all that. So out of those events, that was how NSS came about. So what we're looking to do is that we're looking to see how we can bring people together, particularly Nigerians now, because SJC is a global event, right? It's a global organization, rather. All right. Judith has already spoken about SJC at large. So, but now we want to see how we can incorporate all of that for Nigerians itself. All right. So basically, what we're looking at is it's an annual event, right? And we had the first edition last year. It was hosted at OAU, that's Obafemi Awolowo University, right? And this year, we're hosting it at at Mountaintop University at Ogun State. And the theme for this year's event is the theme for this year's event, yeah, it's the future of space, AI, and data in Nigeria's economy and security, which is in line with the theme for World Space Week, right? And what this theme is all about is We're looking at seeing how AI, how different aspects of technology, that's AI, data security, can be fused with space activities in Nigeria. And all of this is centered towards one goal, right? Towards enhancing the economy of Nigeria and security of Nigeria. All right. We all know that AI and data and that security on its parts, they all play various roles, right, in the tech space, right? They all play various roles in different sectors, right? They can be fused in different forms. So we're looking at seeing how we can incorporate this aspect of technology into space activities, and also seeing how we can use this technology to promote the activities of space in Nigeria and also beyond Nigeria, so that is Africa and the other parts of the world at large. So um, what we're looking, the event is going to be on the 21st of November at Mountain Top University, and we would like you to also register to be delegates in for the event, right? And why we're doing this is because we want you to be a part of a movement, right? We do not want to leave anyone out, because we know that there are lots of people. I myself, from the recent event we've had last year, the one we had at S Nigeria, I met people that when they came for the event, they said that they didn't know that there was any organization or there was any arrangement for space activities in Nigeria like this. But and they were really surprised. They were like eager to participate in things like this more often. So I had to tell them that, oh yeah, we actually do things like this. Just that, okay, probably the awareness is on a minimal level, or it's not well publicized in that sense. So what we're doing is that we want to create more awareness for events like this, to let people know that there's actually a place for them in space. All right, and it's not just I know that many people think that when they hear space, they think about astronaut, they think about every other thing. They think about going to space. They think about, some people think about aviation and all that. But then it's way beyond that. All right, there are different aspects. Even if you're a lawyer, even if you're a tourist expert, even if you are a painter as an artist, if you are a software engineer, if you're a data analyst, if you're an AI engineer, whatever field you're in, right? There's always a space for you in the space community, in the space industry. And there's a chance we can use this activity, these abilities to add value to the progress of space activities within Nigeria. So with this, I would love to inform you all and also invite you all for the event and all that. And at the same time, yeah, we're partnering with SJC and also, yeah, the World Space Week as well. So we just want to create awareness, more awareness about what's going on within the space industry in Nigeria as well. All right. So for more information and all that, right, you can visit our website, which is nigss.org, right? You can visit our website there, or you can also send an email to info@nigss.org. So if you have questions, or if you have and if you have any form of questions, right, you can feel free to reach out to me, or you can send us an email there, or visit our website there. All right. So we'd love to have you all, and we'd love to work with every one of you. So thank you very much.
All right, thank you very much, Mr. Victor from Nigerian Space Symposium. So, right, the link to register for the call for delegates would be in the chat box. So you can, go ahead and please register. Now, for the time we've all been waiting for, we would be announcing or introducing our speaker for today's webinar, Space Robotics and AI, Mr. Abdulganiyu Yusuf. Mr. Yusuf is a Space Science and Technology Officer at the Defense Space Administration, where he advances the integration of artificial intelligence in space technology. His work focuses on enhancing satellite-based systems, including projects that improve troop navigation through GNSS utilities and satellite communication. He explores computer vision, machine learning, and vision language models to strengthen space signal transmission and integrate UAV feeds for more intelligent operations. With a background in computer science, statistics, and data science, he's expanding into cloud computing, network engineering, and DevOps to design efficient, durable systems. Driven by curiosity and impact, Abdulganiyu is committed to pushing the boundaries of space-aided navigation, communication, and exploration. If your hands are not too busy, and even if they are, a round of applause for the speaker of today's webinar, Mr. Abdulganiyu Yusuf. So, Mr. Yusuf, you have the floor, please.
Okay, thank you so much. Thank you so much, everyone. And first and foremost, I would love to say, I thought Sylvester was actually done with my presentation when he started breaking the whole concept down. So I don't know, am I permitted to share? To share my screen?
Oh, yes, yes, definitely.
All right, so thank you. In a minute, I'm coming. Share.
So, guys, at this point, I really want each and every one of us to get our pens or our pencils, as the case may be, and jotters and take this down, right? We don't just want to come to a webinar and just burn our data, right? So, we want to actually take something back. So, let's endeavor to get our pens and pencils and jotters to be able to actually take notes and write something down. So, yes, Mr. Yusuf, you can proceed.
All right, can you see my screen now?
Your screen is completely blank, like white from my side. Okay, yes, I can see your screen now.
Is it better now?
Yes, it is.
All right, so I guess standing by the existing protocol, my name is Yusuf Abdulganiyu, as rightly stated, and it's really exciting time to be talking about space, technology, and human spirit of exploration. Humanity itself has always looked up at stars with so much curiosity. Specifically myself, I could remember some years back when I had my grandmother herself getting to be seated in the compound telling me, can I look up there? Do I see those things blinking up there? Do I believe that a lot of it are not actually stars? I was amazed for her to have known such information as of that time, but it's kind of very important for us to realize that human activities, even in the far outer space, had really been far, far, far back to even the Splunk, like rightly stated earlier. And so humanity itself has really been exploring different kind of areas of space. And I believe here we're all space inclined, and we can really tell what the region of space is in the whole kind of world and atmosphere itself. But not just looking at the space anymore, we are also living and working there. As we move forward into the era of human space flights from the International Space Station, or ISS in short, to lunar missions and future Martian colonies, one question that always stands out is, how can we sustain human life and work efficiently in such extreme environments? Of course, you all can agree with me that the answer lies in robotics and artificial intelligence. These two revolutionary fields that now form the backbone of space operations. Together, they are transforming how astronauts from manual explorers into mission commanders, working alongside intelligent, tireless, enterprise-sized robotic companies. So now we get to talk about why does the space robotics really matters? And I guess even fact is means that we could tell from the outer space, the high radiation rates, the zero gravity, and even as part of the human isolation, limited communication. When you're in space, they're having to be almost 100 kilometers away from Earth. There's a limited form of communication. Though these are all challenging activities whereby you don't get to expose human to such in a very long time. And that is where the point of robotics are coming into play. So human capability alone can't handle all these tasks safely or efficiently. Imagine you have to repair a mission outside the International Space Station where temperatures can swing from 120 degree to minus 150 degree. A small tear in the spacesuit can be very fatal. Robots can perform these high-risk operations, allowing astronauts to focus more on strategic and scientific work. AI enhances this by making those robots smarter, adaptive, and autonomous, able to make decisions, recognize problems, and support astronauts in real time. So together, robotics and AI extend human capabilities beyond physical limits, ensuring safety during dangerous tasks, and of course, optimize mission performance and scientific discovery. So looking at next, we evolution of robotics in space exploration. Space robotics isn't something new. We had Russia always pioneering the whole startups of space exploration. So the story of space exploration dates back as far as 1970s, where you have the lunar rovers of the Soviet Union, which explored Moon's surface remotely. So later, NASA also came to play with their Apollo missions, used simple mechanical arms to collect lunar samples. Lunar here, we're talking about the moon itself. So lunar samples. So from 1990s, the space shuttle era introduced the Canadam. That's the Canadian robotic arm that was created by Canadian that could deploy and capture satellites in the orbit. It was manually controlled, but precise enough to perform delicate tasks in microgravity. These early systems were programmable and not intelligent. Pay true attention here. Programmable and not intelligence. You can actually program something, and definitely it's not just intelligent. So they lacked autonomy. Every command came from the ground station on Earth, but they laid foundation for today's intelligent robotic systems. So coming down to our era now, which is like our the AI generation, where from 2020s to date, we've started experiencing the integration of artificial intelligence, giving the robot the capabilities to autonomously carrying out those kind of tedious tasks that humans were not supposed to be exposed to. So in the next year, we talk about categorizing all these space robotic systems. Specifically for my own sake, I get to categorize it in 3 ways. We look at it inward usage, that's inward assistance. Then we get to look at it at outward assistance. Then we get to look at it at remotely assistance. So when you get to like look at it in a way that is humans operation in space, we have the first one being the orbital robots. That's like the outward assistance. So orbital robots are kind of the robots that move in the orbit. A good example is the Canadam that was mentioned earlier. We have mentioned earlier that the deployment, and it also helps in the capture of satellites in orbit. Then we have the surface rovers, which I'm going to say as the remote assistance. Surface rovers mostly used in Mars exploration. It's helping geological research, sample collection, and search for water and so on in the Mars itself. And then lastly, we have the internal assistant, which is like the astronaut's body or companion. We would explore more on this definitely in our subsequent slides. So we'll go into the next one. This regards to the rise of artificial intelligence in space missions. The power of artificial intelligence accelerating robotic capability. Earlier mentioned that systems can be programmable, but doesn't mean it's intelligent. Now, AI enables these systems to be intelligent. Instead of remotely controlling these machines, we now have the autonomous partners that can perceive, decide, and act. AI enables, I can believe everyone at least have a basic knowledge of AI, which is just a way of mimicking human intelligence that's giving machines the power to reason, to think, and behave like human. So we have different aspects of AI itself. There's a computer vision, which can be help for navigation and object recognition. We have machine learning for predictive maintenance and failure detections. We also have natural language processing for voice-assisted operation, and also autonomous planning for mission scheduling and navigation. So on the International Space Station, AI has been integrated into daily astronaut operations, making space missions safer, faster, and more efficient. The whole idea is all about making the robots more intelligent, and I mean, that's the whole idea of AI in the first place, is just to make the robots more intelligent. Okay, so we now look at some case study here. So like the inward usage, which is where I mentioned the fact that, okay, robots are now being used inward to help astronauts to perform some kind of tasks. A good use case here is the Crew Interactive Mobile Companion, in short called the CMON. It's an AI crew assistant. It's free-flying robot developed by Airbus and it's powered by IBM Watson AI technology. It supports astronauts with verbal, visual, and spatial information retrieval. When we talk about spatial, so that's more of like GIS, Geographic Information Systems. And it's also equipped with voice recognition and sophisticated emotion detection capabilities. What could be more comforting for a lonely astronaut than a companion that speaks to his or her feelings? Now that justifies where it got its name from, which is the companion system. And finally, it acts as a mobile documentation system, reducing crew's reliance on fixed tablets. Let's take a look at the next case study, which here we're going to talk about Astrobi. It's also a NASA free-flying cube robot autonomously, which navigates the International Space Station's corridors. It monitors the environmental conditions, record videos, performs inventory management, freeing astronauts from repetitive tasks. When you get to automate your processes, of course, you are doing away with repetitive tasks. It simply means you have more time to engage in more better activities or more strategic activities, and you'll be more productive. Apart from these two case studies, we have whole lot of other, and we have that of Robonauts 2 developed by the same NASA and General Motors. We have that Canadian, which was mentioned earlier, and others which we get to speak about in subsequent slides. So human-robot collaboration, the idea of having a robot in space and at the same time having humans to collaborate with it is inevitable. And the future of this space exploration relies seamless in the teamwork between human and robot, helping humans deal with dangerous and complex tasks, while humans get to focus on the more strategic and scientific researches. So, robots itself have not really come to kind of take over astronauts itself generally. It's just a way kind of create a collaborative environment where humans get to have a seamless, easy space to kind of perform missions, tasks, and some scientific researches. Remember our classification earlier, what we get to talk about inward assistance, outward assistance, remote assistance. Now we are going to talk about remote assistance, where we discuss Mars exploration rovers. Rovers are like small robots, unmanned ground vehicles, depending on the classification, where you get scientists sending these rovers to Mars. Communication delays make real-time control impossible. Just like when we get to talk about and discuss about programmable and automation. So when you have to program a system, you have to be somehow remotely controlling it. So having to kind of bring in distance between either the transmitter and the source or the receiver and the destination, you get to like realize that a form of the distance introduced between these two systems can cause issue. Either we have issue with the message dropping, or let's say there's a booster even in between this medium of communication. You certainly would experience time delay. Commands from Earth can take up to 10 to 20 minutes to kind of reach the surface. That's the Mars rovers there. And that is why AI is essential in this kind of system to kind of attain autonomy. So we have the curiosity and perseverance, which is what you can see on the screen here. It uses sophisticated autonomous navigation algorithms, that's autonav, to traverse complex terrain, avoid obstacles, and choose optimal paths of aiding navigation. Perseverance even carries a small helicopter they call the Ingenuity, which uses onboard AI to stabilize flight in a Martian air. Then we also have all this integration in this remote system, aids scientific independence, allowing rovers to collect samples, units, identify target analysis, and prioritizing data transmissions based on scientific value that is going to bring. So it doesn't just waste its time trying to just explore any other thing. It can get to look at what really matters, what is going to help whatever research that it was sent there for. Now we get to look at how AI is also important in spacecraft navigation and maintenance. It plays a huge role in keeping spacecraft operational. Particularly, I'm going to cite an example with SpaceX, where they tend to use it in advancement for a series of activities. Number one of it being predictive maintenance systems, which uses machine learning to identify components where before its failures. So it can tend to kind of use for predictive maintenance. 2, navigation AI helps to calculate optimal trajectories. It saves fuel and time. So they don't get to burn fuel whenever they are trying to kind of start go on space embarkment. It's easier for them to kind of project to calculate the whole fuel that is needed in this process. It also has a data-driven diagnostic that can reconfigure systems automatically during anomalies, which is a life-saving capability in deep space, making mission more efficient. As we return to the moon under the NASA's Artemis program, for those of us that don't know, it's a program that returns humans to the moon, establishing a long-term presence and serving as a stepping stone for missions to Mars. Robots will take the lead in building its infrastructure. They will all assemble the habitat, deploy solar arrays, prepare the environment for human arrival. On Mars itself, similar systems will manage life support, monitor radiation, even 3D print spare parts. So getting to see this is like having to push workers down to the Mars. I hope my screen is still visible. Hello.
Yes, yes, it is.
Oh, okay. So that's fine. All right. So having to send workers down to
So we
Mars.
can't see it anymore.
You can't see the screen anymore?
Yes, sir, we can't see it anymore.
Okay, I mean, is it okay now?
Yes, it is. We can see the screen now.
All right, so that's fine. So, like I was saying, I was talking about sending robots down to Mars itself to prepare it as a home for we humans before we get to visit it. Now, which is the whole idea about the NASA's Artemis program. The thing is, they're trying to kind of make as much as possible exploration to even go as far as taking humans to space. Not just the lunar mission, even as far as Mars, which can also be a stepping stone to kind of move to Mars. And while it's there building a home for us, we can just get in and accommodate it as usual. So now we talk about real-world examples, which we have mentioned some slides of them from the case studies here, but at least we're kind of trying to relay the emphasis on it. That's number one, the Canada. It's a 57.7-foot robotic arm used for precision handling. And we said it helps to kind of move or take deploy robots into this, deploy or even remove robots from the orbits. And we have the Astrobi, which is the offline robot, and the human companion, the Simon itself. So I try to lay emphasis on that, so at least we could get to take it home. Now we're also going to look at the future, the possibilities that integration of AI robots into space exploration holds. And this, of course, you can all agree with me, is breathtaking possibilities. Imagine the next frontier where we get to have swarm robotics mining asteroids for rare minerals, or picture an AI-powered habitat that adapts to human needs in real time, or AI colonies running autonomous space station on its own. Machine learning optimizing orbital traffic. I mean, these systems will operate as a co-explorers, learning and evolving with human. The boundaries between astronaut and machine will definitely blur as time goes on, forming a cool partnership in exploration. For everything that is good, there's definitely something bad about it. This is an African saying. So when it comes to autonomy, we also have to consider the ethical usage. We also have to have an ethical consideration or the responsibility, trust that becomes more critical. We must ask ourselves, who is accountable if an AI system fails during a mission? How do we ensure decisions align with human values? How much decision making should we delegate to these machines? How do we entrust transparency and also safety? These questions are key in ethical consideration and must be addressed. AI systems must remain assistive, not authoritative, to ensure that AI systems are transparent, accountable, and safe for human usage in space. Now we're also going to look at the earthly impact of space tech transfer. I mean, the beauty of space innovation is that for any innovation done in space alone is not just used in space. It tends to affect us even on Earth. I attended a conference that was 2 days ago, yesterday and day before yesterday, ITU conference, which specifically talked about the enormous advancements on space exploration have brought to humanity. Now you could see a lot of kind of stakeholders, a lot of people trying to gear into space itself. Space is not just something that looks like a faraway technology any longer. It's something that everybody now wants to be key makers, want to be part of it, especially African communities. So, and this is something that's so much aligned to the SDG goals. So I think space is here to stay, and the only thing is we even yet to explore it as much as it ought to be. So we get to kind of push in to looking more inward. An AI system used for navigation and robotics now power medical surgeries, climate monitoring, and agricultural automations here on Earth. So space technology is more like a mirror. We invent for survival up there, and of course, it also helps to transform life down here. Now we're going to revisit the team itself which spoke about how robotics and AI help astronauts perform tasks. Robots and AI are not replacing astronauts. They are extending human imagination. Astronauts are now focused on discovery while robots handle danger. AI turns data into decisions, chaos into coordination, and missions into milestones. The fusion of human creativity and machine intelligence is the most powerful force driven by space exploration today. So I'm going to end on this keynote that says, when humans and machines work together, we are not just living in space, we are shaping the future of life itself. All right, thank you.
Wow, that was truly an insightful session with Mr. Yusuf. But how many of us took notes? Can I see our hands? Many of us took notes. Okay, okay, okay. All right. So thank you once again for that insightful session, Mr. Yusuf.
Okay, so I think we're in question and answer. If there's any question for me. Hello.
Mercy, you're speaking. We can't hear you.
We
Your
can't
mic is
hear you.
on.
Yeah, sure. So that was absolutely enlightening. So thank you once again for taking us through the world where robotics and AI go beyond what we thought it was, right? To make real human missions possible. So right now we would be taking our question and answer. So if anybody has a question for Mr. Yusuf, feel free to drop your questions in the chat, or you could unmute your mic and speak by raising up your hand. So let's make it sharp and interactive. So you could type your questions in the chat box, or you can unmute your mic and speak. Nobody have questions. Don't we have any questions for Mr. Yusuf? Please don't be shy. Don't be shy. You can ask your questions. It's here to answer your questions. So if you have any questions, you can please unmute your mic and speak. Or if you are too shy to speak, you can type your questions in the chat box, right? All right. So if nobody have, or if since nobody has any questions for Mr. Yusuf, I have one. I have a couple.
I think
So Mr. Yusuf, can you hear me?
there are questions in the chat.
All right. So some people just joined. I know some people joined like while you were speaking. So I want to ask, like, how exactly does artificial intelligence complement human mission or astronauts' mission in space? Like, give us in-depth examples.
Okay. A good example I'm going to get to relate here is first and foremost, I mentioned something about loneliness of human there. When you get to be there, having to perform some tasks, repetitive tasks, having to be all alone there. So there are the things like the innovations are geared towards how can the human being there have a kind of something that helps them with some activities there. That's I even mentioned while I was doing the presentation about classifying it basically into three: the outward assistance, the inward assistance, and also on the remote assistance. For the remote assistance, the whole rovers sent to Mars, to be able to collect different samples of different things, to be able to kind of further explore possibilities of human, whether the place is habitable for a human. And also for the inward assistance, which is where we cited things like the Astro B, the Simon, the human companion there. So these are an example of applications of human robot and AI to assist human in the space itself. I don't know if that's clear enough.
Yes, yes, it is. Yes, it is. So while you were speaking or while you were presenting, you said something about, artificial intelligence or robots in space being some kind of like a partner for astronauts over there. Am I correct?
Definitely,
Like in
definitely.
terms of loneliness, right? So don't you think kind of should they or do you feel they have some kind of emotional accessibility? I mean, for somebody to be my companion, right, in space, so I will not be lonely, as you said. I'll be able to like talk to the person, share my feelings or share my words with the person. So is there a way for this robot or for this artificial intelligence to have like some sort of emotional accessibility?
The last time I checked, going for space exploration does not involve finding partner or love, if I'm to guide you right there. The whole thing about going to space is for activities or tasks to be performed. So in as long as, at least we said Simon has this emotional intelligence. So emotional intelligence there is like be able to say, okay, yeah, you're sad, you're this, your facial expression, can you do some form of recognition there? So that's enough. So any form of personal expression or anything, again, then I think we'll have to look for subsequent advancements.
All right, thank you, sir. So Samuel Adebanjo in the chat box said, yes, I want to ask, what's the future AI and robotics in Nigeria's space industry? What is the future? What is the future AI and robotics in Nigeria's space industry?
All right. So if I get to answer that, I think I will look at it from the military perspective, which is where I'm coming from precisely. And by now, AI is no longer an emerging technology, if I'm to say it's right. It is a technology that is so much advancing that it has really come here to stay. And of course, every form of its potential, its form of test and everything has already been done. Now, for the military application of AI in Nigeria, because now we're all looking towards space, like Mr. Victor Dennis stated in his talk. He said something about using space to aid security, using space to aid any form of activities we do on Earth here, which security is one of the key things here. So we tend to help use it for mapping. We tend to use it for even improving navigation systems. We tend to use it for several things. Looking at the mapping aspect now, we can get to infuse AI into these systems to be able to kind of have a plot of any area of interest, like perfectly, where we get to pinpoint maybe change detections or any form of changes over a period of time, where it can help our troops or may kind of personnel to be able to carry out operations seamlessly. In terms of navigation, or even let's talk about just basic image reconnaissance or image capturing. These AI-enabled systems helps to kind of improve our kind of foresight. It helps to increase the level to which we can get to interpret image captured, either from the satellite imagery or even the UAV systems we have on Earth. And currently, like the project we're working on, like I mentioned, it's part of the kind of intro that I was giving about me, the Troops Navigation System. It's a system whereby we're trying to use AI and in kind of incorporation of with a system that helps to improve our aid capability of navigation or kind of navigating the from form of terrain, not relying just solely on GNSS or GPS systems. But I don't know.
All right. So, sir, we have like so many questions in the chat box, so we won't be able to extensively dwell on like one question. So, can you just help us to go as straight to the point as you can? Thank you very much.
All right.
All right. So, Malik Egbetayo asked, my question goes first. How does AI assist astronauts in high-risk scenarios like equipment failure or medical emergencies? Hmm.
That's deep. For medical,
That's
yeah, for medical emergency, specifically well, if you're talking about space mission, you know, a lot of countries have their astronauts at the International Space Station, and for everything that is required of you to help you survive while you are on your mission, it's being with you, like it accompanies you out of this Earth itself. So I don't think for AI itself cannot start running diagnosis or start running medical this thing. The only thing to a limit of what it's been trained on, that's what assistance can offer. But remember, the medical emergency is out of something that was probably planned for during your own mission. I don't think something can be worked on there. So that's my take.
all right. Thank you very much. So, Samuel, does that answer your question, please? All right. So, moving on, we have quite a few questions from Mr. Sina Desu, who is the chair of African Planetarium Association. And our question goes thus: Our robotic systems designed to operate in extreme space environments, such as low gravity or high radiation? And also, what are the main challenges in developing autonomous robots for planetary exploration? So the first question, our robotic system designed to operate in extreme space environments, such as low gravity or high radiation?
Okay. For in low gravity system, if you want to look at the robotic system designed to operate in extreme space system, there are a lot of considerations are put. Firstly, in the terms of coating of the robot itself, in the kind of materials that will be used, it has to be materials that can kind of endure kind of high and maybe endure a serious radiation, which is something that was used to create the suit even the astronaut themselves put on. So for high radiation, that has to do with the coating of the robot's material itself. Then, of course, during the gravity, like the Canadian we mentioned, it works efficiently. It's able to maneuver in kind of a gravity condition. So there's always a form of pretest that would have been done in here on Earth that before it's been taken there. So I get a look into deeper understanding of that would necessarily be done. And the second question is what?
What are the main challenges in developing autonomous robots for planetary exploration?
The key challenge here, if I'm going to cite an example with the rover systems, mostly it has to do, okay, from the major ones that I have read about, which is form of communication between the base station here on Earth and the rovers on the planetary system. So there's always that issue with communication and the time delay and lags that happens with it. But for the AI integration capability that they tend to be looking at right now is the fact of even just helping these robots getting to do the work itself, and why it relieves human to having to telemetry or send a kind of commands from here space. I don't know if that answers it.
All right. Thank you very much. So, Mrs. or Miss Desu, if that answered your question, can we see your virtual reactions? So, moving on to the next question from David. It says, good afternoon. I just wanted to add, could robotics eventually replace astronauts in hazardous missions? And if so, should they?
Yeah, we said it already. Robots are not there to replace astronauts. They are there to assist astronauts. Of course, taking on a hazardous task will definitely be the robot box, but it's left to human now to kind of possibly interpret whatever had been gotten from the robot. I don't know if that answered.
All right. Thank you very much. So, Eniola and Fathia, could you help us mute your mics, please? Thank you very much. So, on to the next question from Samuel Adebanjo. Says, what advice can you give young engineers trying to specialize aerospace robotics and artificial intelligence?
For any skills you're trying to get, it's very important to always understand kind of the requirements, which in terms of talking about hands-on, getting to understand the tools that are required to be able to kind of effectively kind of make an impact. And most advice I give to anyone trying to explore this field is trying to find who are the people or some form of mentors that can get to guide you while you're navigating this path. Because if you agree with me, there's little spaces in Nigeria that tends to kind of practice this in best way. So you find young graduates that are into these systems or try to learn or explore, they have limitation of the exposure they get in this arena. So most importantly, try and get mentors. Being part of this form of community, it helps you to kind of grow and expose yourself much better. Yeah, that's all.
All right, thank you very much. I really hope that answers your question, Samuel. All right, so nextly says what kind of sensors are commonly used in space robotics and how are they calibrated for accuracy?
Sensors, now if you're talking about sensors, you definitely have to talk about either object collision avoidance systems. Then you're also having to talk about even the cameras itself necessary to kind of help in computer aided vision. Then the kind of all this, firstly, once you understand, for any robot to be sent to space, it's tested on Earth here first. So any form of kind of situation it might encounter while being in space, it's tested here on Earth. So the necessary, either the gyroscope or any form of sensors that is needed to kind of help navigate on top the kind of mission it is, or even anything that has to be put to a form of a collision avoidance, or even for the camera itself for a good image understanding and discovery and everything like that. So it's all being tested here first. So I don't know if that answers it.
All right, thank you, sir. I really hope that has answered your question. All right, so Ms. Desu has another question. Again, I have a dual master's in astronomy and astrophysics. Okay, also a software engineer. So can I join on space robotics technology?
Definitely, definitely. You even have a very good combination. Astronomy itself and astrophysics is very perfect. Having software engineering would make it much easier to be able to kind of build systems that work for this. There are two different disciplines. So I think that's, yeah, definitely good to go.
Oh, all right. Thank you very much, sir. I really hope that has answered your question, ma'am. So we have another question from God's favor. He says, how do robotics and AI assist astronauts in performing complex tasks in space, such as maintenance and repairs?
Now you're getting to look at the era of arena of machine learning, where you get to help with predictive analysis. I don't know if you have a good understanding of how AI works generally. Specifically, you have to get to train it to be able to understand something that would go wrong, in the sense that there's a form of, you should have been pre-trained with some form of set that says, if this happens, there's a form of anomaly. Then if this happens, there's a form of this, then it calls for, it's alert for maybe maintenance. So it's pre-trained before it's been deployed for usage. That's the short answer I can give.
All right. Thank you very much, sir. So another question. How do robotic teams test and simulate conditions on Mars or the moon?
Okay, I'm trying to get, let me see if I can locate this, about how they test even zero gravity here on Earth. There's always a form of a lab, specifically by NASA or any space agency, that tends to kind of help. Even it's open, is commercialized, that even every other person can get to use this system. It feels like you are in space. So those kind of labs helps to build space technologies. So the fact that they are able to kind of simulate such things there, so even if there's going to be a little bit of discrepancies, it will be minute or little. And of course, subsequently, they're always upgrading the lab to meet up with the kind of actualization they see while in the space. So there's a sample place for them to test that on Earth here.
All right, thank you very much, sir. So we're taking one last question. So Miss or Mrs. Abosade Egolu, I really hope I'm pronouncing your name correctly. You said you have a question. So ma'am, you can unmute your mic and speak. Abosede Egolum, are you on the call, please? If you are, you can unmute your mic and speak. All right. I think that'll be all for now. But if you have any more questions, you can please unmute your mic and speak, right? Or you can type them in the chat box. We're giving room for one more question. So if you have any question at all in relation to space, robotics, and AI, you can ask. So Abosede Egolum has just joined the call again. So ma'am, you can unmute your mic and speak and ask your question. Abosede Egolum, are you on the call, please? All right. So in the absence of, okay, she's on the call but not responding. Thank you so much, Muhammad. So that will be all for our question and answer session. So on behalf of Space Club LASU and every one of us on this call, I want to say thank you so much, Mr. Yusuf, for trying your possible best to answer each and every one of our questions. One thing I would really commend was how articulate you were in answering the questions. There were no filler words, no and but. Nicola, I'm giving a question, you're giving me back the answer with such alacrity. So thank you so much, sir. A round of applause for him, please. A round of applause for him. All right, so now we would be taking a brief of what Space Week events. Okay, we'll be taking a brief of what Space Week events and the movie night we'll be having tomorrow. And to anchor this, we'd have Kenny Ayodele. So Kenny, you have the floor, please.
Good evening, everybody. Can you hear me? Thank you. So, I will be, in fact, taking the following events that we'll be having soon. We'll be having our movie night very soon, and it's going to be a very, 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 very fun and engaging event. And I can't wait for us to see what movie we decide to use. And it's going to be very, 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 very interesting, very, very engaging, and you don't want to miss it. So make sure to show up for that. And I'm going to be taking the introduction about space clubs. I'm going to be taking the introduction about space clubs as well, if we can get that slide. So for those who don't know about space clubs, Space Club LASU is a student-led community. We're a passionate community of space enthusiasts, researchers, and innovators dedicated to exploring the mysteries of the universe and inspiring the next generation of space explorers. Our mission is to inspire, to share our passion for space exploration through public events like this webinar and outreach programs. To educate, we provide hands-on learning opportunities and workshops for students interested in space science and technology. We also engage, we conduct cutting-edge research and experiments in space science and technology. That's what we do. We empower the next generation of space explorers through education, innovation, and hands-on experiences. We envision a future where space club members become pioneers in space-related fields, pushing the boundaries of knowledge and contributing to the global exploration of the cosmos. Together, we aspire to create a legacy that inspires generations to come. So you can find us on LinkedIn, Twitter, and Instagram. On LinkedIn, you can find us on Space Clubs at Lagos State University. You can find us on Instagram, LASU_space, and on X also, LASU_space. Thank you very much.
All right. Thank you very much, Kende. So what she said was basically a brief introduction of Space Club's LASU, right? What we are and what we stand for, right? So next we'll be having a brief of the World Space Week events and the movie night, right? So and that will be taken by Kende for doing our Vice President. So a round of applause for him, please. So Kenny, you have the floor, please.
Good evening, everyone. I want to confirm you can all hear me. If you can just send the virtual reaction, I'll appreciate it. Okay, thank you very much, Sylvester. Thank you, Malik. So, World Space Week started on October 4, 2025, with the theme Living in Space. And we had our very first webinar with the topic Space for All, with a focus on why living in space matters to life on Earth. And it was a very insightful webinar, and we all learned a lot. The second event of the week was our call for articles, and the call for articles is currently still going on. It's going to end on the 13th of October, and there are prizes to be won. There are opportunities to be won, and you stand to gain a lot of opportunities if you submit an article. The third event was part of our secondary school outreach series, where we visited the secondary school, there's Rosnick schools, and we basically told secondary school students what space is about. We inspired them to pursue a career in space. We told them why we celebrate World Space Week, and we answered a lot of questions that they had for us. And trust me, these students were very, very, very inspired. They were very, very curious about space exploration. And we were able to just do that, just inspire, educate, and engage students in the wonders of space. Our fourth event was a virtual hackathon, and this is one of the most interesting events that we've held so far in this week. We saw students come together in teams to work together to collaborate and share innovative ideas, right? And we also have prizes for our winners, though they've not yet been announced, but stay tuned for the announcements. Yesterday, we also visited the secondary school, Temerage College, as part of our World Space Week outreach series. We also inspired students in the wonders of space. We sparked their interest in space exploration, everything about space. And trust me, these students were actually brilliant and sharp minds. We answered a lot of their questions. And currently, our sixth event is one we're having today, the one you are on currently, which is our banner, right? And I hope we've learned a lot. So tomorrow, we'll be having our last event, which we are going to use to wrap up World Space Week 2025, which is going to be a movie night. Now, the movie we are going to be showing tomorrow is a very, very interesting one, and you don't want to miss it. So it's going to start by 6 p.m. tomorrow at the school boatry. If you're in Lagos State University Ekpe campus, it's a physical event for you to attend, right? So time is 6 p.m. and it's going to be happening at the school boatry. So thank you very much for having me. Over to you, Messi.
All right, thank you very much, Kenny. So, as you've heard him, we'll be wrapping up World Space Week with a very interesting movie night that we'll be having tomorrow. So, if you're in LASU, you can, come down at the butchery to enjoy this spectacular event that we've planned out for you. Even if you are not in Ekpe, you can, you can make plans to come join us. And we promise you it's going to be an amazing one. So now we'll be taking the membership details and application process. The membership details and application process, right? So for those who are wondering how to become a part of this amazing community, so Yusuf Atolagbe will now take us through the membership process and how we can officially join. So Yusuf, you have the floor, please. And yes, Yusuf Atolagbe is our project lead too. So Yusuf, you can speak.
Greetings, everyone. I am Atolagbe Yusuf Oladotun, and I'll be explaining the membership details and application process for Space Clubs, Lagos State University. To become a member of this wonderful organization, you simply go to spaceclubslasu.org. Once you're there, you will find the application form where you'll be asked to provide details regarding your personal information. You'll be asked about your academic details. You'll be asked to provide social media links, and you'll be asked about your areas of interest.
and a personal statement expressing your thoughts and enthusiasm for space. And please, when filling out these details, let your responses reflect your passion for space. So we strongly advise against the usage of AI for your responses. After the application period closes, all applicants will receive an email containing the next steps to follow. Following that, there will be a physical interview where shortlisted applicants will meet with the selection team. So if you're selected, you officially become a member of this community. The membership application opened on the 28th of September and will close on the 17th of this month. So after the 17th, all aspirants who have filled out the form on the website will receive an email with the necessary steps to take. Membership is open to all students of Lagos State University, regardless of your faculty or department, as long as you have interest in space, science, or space technology. You're welcome to join us. If you haven't applied, then don't miss this opportunity. Visit our website, spacecraft.lasu.org now. Thank you very much.
All right, thank you, Yusuf, for that one. So you've heard it, everyone. Don't just watch, get involved. Space Club LASU is not just for engineering students, right? Whether you are in LASU Com, Keja, whether you are in LASU or JOS, Space Clubs is for everyone, right? So there are some communities you would be involved in, or some communities you would join, and you just take pride in being in that community. And for me, Space Club LASU is one of those communities. So you've heard Yusuf, applications will be closing on the 17th of this month. So fill out your applications and check your email after the applications has been closed. So thank you, everyone. All right, to wrap up tonight's session, we'll take a vote of thanks from our Vice President, Kende Oduri. Mr. Kenny, you have the floor.
Right. Thank you very much, Messi. On behalf of Space Clubs LASU, and of course, in partnership with the Space Generation Advisory Council, I'd like to express our gratitude to everyone for making today's webinar a success. I really appreciate everyone's effort and time to make that we made out to be on this call. First and foremost, our sincere appreciation goes to our speaker, Mr. Yusuf. Thank you for taking out the time, sir, to share an inspiring session with us. Your presentation was not just enlightening, but it has ignited in us a deeper curiosity about space science, AI, robotics, and space exploration in general. Also, I would like to thank every Space Club member who worked tirelessly in helping us post our graphics, in helping us telling people to attend this webinar. Thank you for being a part of something truly inspiring. So our participants and everyone on this call, a big thank you for joining us. A big thank you for joining us. Thank you for your active engagement throughout the session. And for those who have been following us from day one of the World Space Week, who's also on this call today, thank you very much. Really appreciate. Finally, I want to appreciate especially Nelly. I think she's on this call from Space Generation Advisory Council. Thank you for your partnership and thank you for sharing a great goal with us. As we bring this session to a close, let's remember that every great discovery begins with curiosity, right? And every small step brings us closer to the stars. In the words of Neil Armstrong, when he landed on the moon for the first time, yes, it was a big step for man and a giant leap for mankind. So please don't let us be afraid to take whatever step we have to take. Just take that step, right? You never know if it's going to be a giant leap for mankind. Thank you all and have a wonderful day ahead. Ad Astra Paraspera.
Ad Astra Paraspera. Thank you for that one, Mr. Foduri. Right. So on behalf of Space Club LASU, we say thank you to each and every one of you on this call, right? You guys made this webinar possible. So my name is Mercy Obano, and it's been a pleasure hosting you this evening. So until next time, keep reaching for the stars and keep building the future you dream of. Thank you and have a lovely evening. Bye.
Thank you, guys. I think we can all leave the call now. Thank you. Before you leave the call, please ensure to follow us on LinkedIn and on X. You can also